again, and welcome back to another FMOD and Unity tutorial, where today we are doing audio occlusion, which is something we haven't done in a very long time, not since probably about 2 years ago when we last did it. In case you don't know, audio occlusion is simply when something blocks the path between your sound and your player in the game, and so you'd expect to get kind of like a muffled sound like that. The best way I like to think of it is imagine you're outside a nightclub. You can hear all the music, but all you can hear is the bass. That's the kind of effect we want to recreate in our game today. Before we get started, I just want to quickly let you know that the FMOD and Unity Essentials course is going to be making its return very soon. In case you don't know, it's a course I set up that basically gives you all the tools and all the understanding you need to use FMOD and its API and the code that comes with it inside Unity and C# to start implementing your music or your sound into any game you want, really. So that's going to be coming very soon. I'm not going to talk about it too much here, but keep an eye out and an ear out on this channel and on my Twitter and stuff. There's even a newsletter on my website you can sign up if you want to hear about all the updates and all the stuff I've been adding to it since its last release. But anyway, like I said, today we're not interested in that. We're interested in audio occlusion. Now what I've done is I've set up a few examples of audio occlusion. One of them is using the old method that I talked about in a video a couple of years ago that's now out of date. Doesn't work with FMOD 2.0 and is a little bit rubbish. I'm going to talk about why it's rubbish in a bit. And the other two are two examples of the new script I've created. One is with music and one is with just an NPC talking to give you an idea of how it's going to kind of sound and how you can kind of use the features in the script to change settings depending on the sound you want to use this for. Also, before we continue, you might hear a dog snoring in the background or a weird noise. That's my dog, just a heads up. Okay, so I'm going to quickly walk you through a couple of these examples. Then I'm going to show you how to use the script itself so that if you want, you can just copy the script off of my website, which again will be linked underneath this video, and you don't have to worry about learning how to code it yourself. But if you do want to learn how the code kind of works, I'll explain all of that after I've demonstrated how it works and how you can use the script. Sound good? Good. Right, so let's jump into it. Like I said, the first thing we're going to do is have a look at the old script, and I'm going to kind of explain why this needed updating. So, I believe it's over here. Okay, so let's zoom in. Right, so here we go. So this little circle in the center is our sound, and this little camera symbol is the player, right? And the line is basically a line cast, which I'll talk about more in a second. But basically, we use this line to check if anything's obstructing the path between the sound and the listener. Now, at the moment, nothing's obstructing it, so we can hear it quite clearly. It's probably a bit too loud, actually. But look what happens if I move behind this wall. It gets occluded, right? And you can see that the line changes colour to tell us that it's been occluded, right? Now, this works. It's great. Well, it doesn't anymore, but it did work. It got us started. The problem is it wasn't very realistic, especially when using it for big sounds like music. Let me explain what I mean. So if I come over here, and if I stand behind one of these little thin posts here, the audio is completely occluded, which is not really what you'd expect in real life. You'd expect it to be sort of occluded a little bit, but not completely in the same manner that it would be if I stood behind a thick wall like this. So the new script I'm going to show you kind of fixes that, and I'm going to show you that in a little bit in a second. We also don't get any occlusion if I stand behind something like this. So, you know, whilst the path between me and the sound is direct, there's nothing blocking it, we are, as you can see, behind this wall, which would kind of occlude the sound a little bit, but not too much. So that's something else that this new script is going to fix. And also, if I come down here, again, you'd expect it to be occluded a little bit based on the walls that are sort of next to the player here, but it's not. So yeah, that's the problem with the old script. So we're going to look at how we can fix it. Now, before I quickly show you my script, I want to show you this video. This is a video that was uploaded by the guys who made Quantum Break. Well, particularly the guys who did the audio for Quantum Break. And this is kind of where I got the idea for improving our audio script. There's a little bit, I'm not going to show you the whole thing, but there is a little bit, if I zoom in a bit, or not zoom in, if I skip ahead a little bit, it kind of shows you how their occlusion system works. And it's here, it's with these lines here. So in our old script, we had one line, right? But here you can see they've got loads of lines. Not only have they got lines going from the sound source, which is this person here, to the listener, but they've also got lines going from both the sides of the sound source and the side of the listener. And then they check to see if they're being obstructed In this case, these lines here are being obstructed by a wall. And what they do is for each line that is being obstructed, they apply the occlusion effect or the filter a little bit and a little bit more for each line. So what they can do with this is basically create a gradual occlusion effect that kind of depends on how far you are behind a wall or not. If I keep playing, you'll see this guy's going to move behind the wall, and whilst I'm not going to play the audio because I'm about to play it in my scene, you should see the lines turn red as he gets more occluded, which again will occlude the sound a little more. So then you don't get this kind of on-off switch effect from the old one. So that's what we're going to do. Definitely check that video out for yourself, because there's more than just that in it. And I'll have that again linked underneath this video. So let's check out how I set that up inside Unity and FMOD. Okay, so if I start walking over to this music object now, you can see all the lines appear. Cool, right? So if nothing's obstructing me and the music, we hear it in full. But if I start to slowly go behind this brick wall, see, we get a kind of half and half effect. It's slightly occluded, but not completely, which is a bit more of what you'd expect to happen in real life. So if I keep going, a little bit more, a little bit more, and then finally we're completely occluded. How cool is that? Now if I stand behind one of these posts, it's a little bit occluded, not completely occluded. If I stand in between these posts, originally because we only had the one line in the center, you wouldn't hear any occlusion, but now we do hear a little bit because of the sides. What I can also do is walk down this tunnel. And again, we just hear a little bit. It's not too much, but it feels a lot more believable than it did originally. Now, what's cool about the script that I've created, and this is kind of optional, we don't have to do this, but not only have I done lines that sit on the X and the Z axis, which is what they did in that original video, I've also done a couple of lines that sit on the Y axis as well, as you can see here. So it's checking to see if anything is kind of, you know, slightly above or below the listener, and then that occludes it a little bit as well, which is what we're getting here. Very subtle. And then finally, if I stand in this little box, like I explained earlier, we expect a little bit of occlusion, but not completely. Or rather, with the old one, we weren't getting any. Now we're getting a little bit, even though the direct line between the sound and the listener isn't obstructed, but the lines around them are. So how cool is that? Okay, so that's the occlusion script working and, you know, doing its stuff. Let's quickly take a look at the script itself, or at least the interface for it, in case you just want to grab this and start using it in some of your projects. So, it looks like this. What you do is simply attach it to your sound source in your game, select a 3D event from it within your FMOD project that you want to start occluding. Now, the way I've set up the script is the sound is simply going to play as soon as the game starts, and then it will finish when it finishes, unless you loop it, in which case it will just continue to play forever. Now, obviously, you might not want your audio to play like that, which is why I'll show you the script in a bit, and you can kind of change that if you want. But for the sake of demonstrating occlusion in this video, that's just how I set up the audio here. Yeah, all the occlusion stuff is underneath it. So as you can see, we've got two sliders here. One is called sound occlusion widening, the other is player occlusion widening. So what this basically does is it's going to widen the starting points of those lines. As I mentioned earlier, not only do we have a line directly from the listener and the sound source, we've got a few lines from sort of points a little bit to the left, right, and above both the sound source and the listener. So what you can do with these sliders is actually adjust them. You can make them wider for bigger sounds like music, or you can make them smaller for like NPCs or someone talking. So this is for the music. As you can see, the points that are, you know, next to the music casting these lines, they're pretty wide. I've set this to 1.81 because it's meant to be like quite a loud piece, like coming from a big speaker basically is what I imagine this music being. But if I make my way over to my other sound source, which is someone talking, I can show you how I set that up. So that's only, the sound occlusion winding is only 0.8. So I'm just going to quickly run over there and you'll be able to see the difference. There we go. So you can see that the points beside the sound source, they're a lot more narrow. Because the size of the sound is smaller, you know, it's coming from someone's mouth as opposed to a big speaker, you know, we don't want the widening too much. So that's obviously going to affect how things are going to be occluded. So if I walk down this narrow corridor, the kind of sides, that occlusion effect isn't happening as much as it did with the music because we haven't made the occlusion widening as big. Again, when I stand behind this brick wall that has a little gap in between, we're not getting as much as occlusion because the sounds, or rather the line casts, haven't been widened out as much as they did with the music. You can also do the same with the player. If you want the player's occlusion widening to get bigger, you can increase that. That's an option you have per instance of the sound, but you're more than likely going to want to keep that the same for each instance because obviously, you know, the player's not really going to change that much, or the size of them anyway. Expect that to be quite consistent, but it's there if you want to change it. But feel free to just experiment with these sliders and try to get a feel for what suits each sound. They're there if you want. If you want, you could even set them to 0 like that so that you don't get the points either side of either the listener or, if I quickly make that bigger, or the sound source, just like that. If you feel that works better in your game. It's something you're going to have to experiment a bit with. But yeah, that's how occlusion widening works. We've also got an option called occlusion layer. Now, the way this works is that it basically, you basically give it a layer in Unity, a layer of game objects that you want to check for occlusion, basically. You don't want these line casts to, you know, start occluding if it hits anything, because that anything might not be the thing you want to occlude, if that makes sense. So, for example, some of these lines, especially with the music where it's so wide, some of these lines, they kind of start underneath the floor, right? Now, the floor is something I don't want to be checked for to occlude my sound. So that's where the occlusion layer comes in. If I click on the game object that is the floor and go to the layer up top here, you can see the layer hasn't been set because obviously this is just a little demo. It most likely would be set in a proper game. But if I go to some of the objects surrounding the music, they're all under the environment layer. So that's what we're checking. If the line is hit by an object that exists in the environment layer, that's when we want to start occluding our sound. So like I said, it just prevents objects that you don't want to occlude your audio, occluding your audio. Brilliant. Okay, I think we're good to go on the demonstration side of things. So like I said, if you just want to quickly start using this script in your projects, head on over to my website and you can just copy the script there. But if you're interested in learning how it works, well, stick around because it's time to dissect this beautiful script and see how it functions. Okay, here we are in the script and there is quite a lot going on. So there's quite a bit to go through. But I'm hoping if we break this down, it's, you know, some of the stuff, like, as you can see here, it's pretty much a copy and paste, you know, where we've got all those lines, we need to do the same thing over and over again. So hopefully once we get the basics and, you know, the key components of this script understood, you'll be able to understand what's going on in the rest of it. So starting off, let's have a look at some of these variables and also the namespaces I've added at the top here. So if you've watched any of my old videos, or if you know a little bit of the basics behind FMOD's API, you'll know that a lot of the sort of variables, a lot of the functions you use start with things like FMOD Unity or FMOD.studio. So for example, event instances here, which is a variable you use to create an instance of your FMOD events to then play back in your scene, you normally have to write them like this: FMOD.studio.event instance, and then name it and then do whatever to it, like you can see here. But what I've done at the top is I've actually included the namespaces at the top with the namespaces. So I've said using FMOD Unity and using FMOD Studio. So that means we no longer have to constantly write them out for things like our event instances, anything to do with the runtime manager, like the create instance variable, that's all gone. Function rather, that's all gone. So yeah, that just makes the script a little bit shorter and a bit easier to see and understand. Okay, so inside the class itself, the first thing we've got is a load of variables that are to do with the audio itself. There are a load of FMOD variables. I've also added the header FMOD event, which is that's just a bit of text basically. That's, if I go back into Unity, that's literally just going to display that there, FMOD event. So that's, you know, nothing important to worry about. Now the first variable I've got is a private string variable called select audio. This is the variable you see in Unity. There it is, select audio, and this just allows you to pick the event you want to play. I've made it private. In fact, I made all of my variables private because I don't want them to be used by another script or another class in either my game or the game you might be using this in, so that's why they're all private. But in order to access it through Unity, I've made sure it is a serialized field, which is this attribute here. So you just write in squared brackets, serialized field, and you'll be able to use it in Unity. I've also added this FMOD attribute, event ref, which is what not only, well, the serialized field bit displays it in Unity, but event ref allows us to, it gives us this search tool and allows us to look for specific FMOD events. So that's very handy. Next under that, we have our event instance called audio. This is going to store an instance of either our music or the person talking. So if I quickly jump into FMOD, this is just a little simple FMOD project I've set up for this demonstration. Ignore these three, these are old, we've done them before. What we're looking at today is music and talking, and we're also going to look at the parameter I've created for occluding them in a little bit. But basically, using the, let's go back to it, using event instance audio, or rather, sorry, using the select audio string variable, we can select either one of those two events, right? Then, which I'll show you in a little bit, they're going to be stored inside the audio variable, which is what we're going to tell to play, to stop, and do whatever. Underneath that, we have a variable of the event description type. This is an FMOD variable type called audio des, short for audio description. Now, we haven't really looked at event description variables, well, at all, on this channel, so let's quickly talk about them. They're basically a way of accessing information about a particular event. Unlike event instances create a copy or an instance of your event. So say, for example, let's go back to FMOD. If I stored an instance of the talking event inside that audio variable, the event instance, we've got a copy of it, and we could do that multiple times. So we could have multiple copies of the talking event. Event description doesn't work like that. It kind of accesses, if that's how you say that word, the event specifically. So none of the copies, just the event itself. And all it's doing is it's going to pull information from FMOD into our script that we can use, and we will be using later on in order to control some features with our script. So I'm going to talk about that again as we get to it. Next is the studio listener. So this is basically a variable of the studio listener type. And what we're going to do is store a reference to our studio listener component inside this variable. So let's go back into Unity. So obviously the way this works, like I said, is that it finds, the script needs to not only find where the sound exists in our game, but also where the listener is or where the player is. Now, this is designed for a first-person game, right? So in first-person games, you'll have a camera attached to an object, and you'll also have a kind of audio listener component. And basically, all the 3D sounds in your game are going to be directed to that component because that's where the player is. That's where the player's ears are, essentially. So if I go to my FPS controller, which, by the way, is just the default controller you can get from the Unity Asset Store. If you search for standard assets, you can download it there. You can see I've got two objects. One's a child of the other. The first one's called FPS controller, and this is just like controlling movement and stuff like that. If I click on the child object, this is the camera, essentially, and this is what I've attached my audio listener to. Or sorry, my studio listener, because that's the FMOD version, which is this component here, studio listener. So if I quickly zoom into my player a little bit, you can see this little, well, hopefully you can see that, it's quite small, but where these little arrows are coming from, that's basically where not only our camera's positioned, but where our ears, the player's ears, the studio listener component is attached to as well. So what this script is going to do, no matter what sound source it's attached to, whether it's the music or the person talking, is it's going to find that wherever that studio listener component is in our game, and it's going to reference it, store that inside this variable here called listener. And then whenever we want to access it, we just have to use this variable here. But again, I'll explain that in a little bit. Finally, the last variable for the audio is a playback state variable called PB. Now, in a little bit, we're going to use this to basically check to see if the audio is playing or not. And I'll explain why in a bit. Next, we've got our audio occlusion options. Again, I've got a little header just so in Unity, we can kind of organize all these variables a bit. They're serialized, or two of them are serialized. No, sorry, all of them are serialized. So again, we can see them all in Unity, even though that they're private. And two of them have ranges. So obviously, I mean, you can change this if you want, but I felt it was a bit unnecessary to say, you can set the occlusion winding to as big as you want, because that'd get a bit ridiculous. So I've just set the range between 0 and 10 for both of them, and the default value is 1. So you can adjust the values of those between 0 and 10. So you can do that for both the sound occlusion widening feature and the player occlusion widening feature, okay? Then underneath that, we've got the occlusion layer variable, which is of the type layer mask. Those previous two variables, by the way, they were of the float type, so they just take simple numbers. But this is the layer mask type, so this will only accept. Well, we've done layer mask before, and they're a little bit complicated to go into the details of, so we're not going to bother. All you need to know is that using this variable, we can give it a number, I guess, or just a layer. Let's quickly have a look at them. That's a bit easier to explain. So if I go to add layer, here's all the layers in our game, and as you can see, you can add your own ones. They've all got a number next to, so we just need to select which numbers we want to check for with our script. Finally, we've got a few extra variables that I didn't want to appear in Unity. These I'm going to kind of have to explain as we start using them, because they depend. The way they work is based on their context. So audio is virtual. We're going to check to see if our event is virtual or not. I'll explain that in a bit. Max distance, we want to check how far the player is from the sound source. I'll tell you what, we'll come back to all these because they're pretty simple. The types are Boolean, so that this first one's just going to be true or false. The rest take numbers, and this last one basically takes a color type. So in Unity, you can basically set colors. This is just for the lines, essentially. So you may have noticed when some of the lines were occluded, they turned red. And also, if we set the occlusion widening to 0, it turned blue. This is basically what that variable's for. It's just going to hold a color, basically. Red, blue, or green. Quite simple. So let's have a look at our first function and start to understand how some of these variables are used. Okay, so in the start function, the function that runs on the very first frame that the game starts on, the first thing we're going to do is create an instance of whatever event we've inputted into the select audio variable. So like I said earlier, in Unity, we're going to pick the event we want to play. Then inside our script, we create an instance of that event. So a copy of it, essentially. And then that's going to get stored inside the variable called audio, okay? Next, we're going to use the attach instance to GameObject function. What this is going to do is simply make it 3D, essentially. So we're telling our script that we want to place this audio in the same position as the game object that we've attached this script to. So for example, if I go to my music object, that line is basically saying play the music at the same position as the object itself that it's attached to, right? Nice and easy. So to get this function to work, you feed it the audio you want to play, as well as you check you check the transform component of the object, which is just the coordinates where it exists in the world. And you also check to see if it has a rigid body component. This one doesn't, but you still check anyway. That's how it works. Next, we tell it to start playing, essentially. That's nice and easy. So as soon as the first frame runs, and we've not only got an instance of our event, and we've also positioned it somewhere in our world, we tell it to play. And then the release function underneath, that's basically saying once the event stops playing, we want to destroy that instance that we created up here because we're no longer using it. Now, again, this is what I was explaining earlier. I can't see many instances where you want music to just start at the beginning of your game and just continue to play. Sorry, sound in general. So this is what you'll probably want to change and adjust, and so you can get your audio doing whatever you want. Maybe you've got some sounds for an enemy's footstep and you want that to occlude. That's obviously not going to play on the very start of the scene. You're going to want to sync that up to an animation. So yeah, feel free to change that as you wish. Underneath that, we're doing some stuff with our new event description variable. So let's talk about this. And the first thing we're doing is we're taking our variable and we want to assign an event to it in the same way that we assigned an event to our event instance variable. Except we don't use the create instance function, we use the get event description function. So that just takes a string of our event path, which again, I've explained already, we've assigned to select audio. And yeah, that's basically going to store a reference to an event inside the audio description variable that you created. So now using this variable, we can access a specific event. And then underneath that, I'm using the get maximum distance function. Now this is a really cool function. So what this is going to do is it's going to take the event we assigned to audio description, right? Then it's going to check to see the maximum distance we set to its spatializer component, okay? Then what it does is it outputs whatever value that was into a variable. So the variable I've chosen is this float variable, max distance. So let's go. Hold on, I'm sorry. I'm going to have to stop my dog snoring. I don't know if you can hear that, but I can. It's really distracting. There we go. You just couldn't stop snoring, could you, Vinny? Ooh, be loud. Come Come on, mate, out you come. There we go. Sweet dog, but my God, does he snore? He's so loud. Okay, so like I said, the get max distance function, what it's going to do is it's going to find the value, which I'm going to show you in a second, and it's going to output it into this variable max distance, and then we can check that and do other stuff with it in a little bit. So what value is it pulling? Well, let's go to FMOD. Let's take our music event, for example. Let's say we assigned that to our script. This is the music, this is the event we want to play and do occlusion with. Well, what it's going to do is it's going to come down to the spatializer effect or component, whatever you want to call this, which will always be attached to your 3D events in FMOD. It's basically going to pull this value here, the maximum distance of the distance attenuation curve. So obviously the distance attenuation curve, it sets values for when you want the audio to start to fade out as the player starts walking away from the sound. The minimum value is when we first start to hear it drop. So I can adjust this if I want to say 5. And then if the player is between 0 and 5 distance of the music, we won't hear any change in volume. But once it goes over 5, it's going to start to drop ever so slightly following this curve here. And then once it hits 30, that's when it's basically, that's the end of the curve essentially. So that's when we're going to stop hearing our audio. So all that function is doing is it's pulling that value 30 and it's assigning it to this maximum distance variable. If I go back into FMOD and actually, if we take a look at the talking event as well, you can see the value for this is actually 20. So in that instance, 20 is going to be assigned to max distance. And I'll explain why we're doing that in a little second. But all you need to know is we're basically finding out how far the player needs to be from this event before the event stops playing, or rather we can't hear the event anymore. Finally, what we're doing is using the find object of type function, and this is, like I said earlier, it's going to find the studio listener component in our scene, and it's going to assign it to that variable. So now all we have to do is, whenever we want to, check things like the distance between the sound and the listener, we can just use this listener variable here. Now this works assuming that there's only one studio listener component attached to any game object in your scene. Basically, it only works for single-player games, is what I'm trying to say. If you had a multiplayer game, what you would do is attach multiple copies of this component to different players or different, little game objects that the players can control, and you give them separate listener index, which is something I need to do in a future video at some point. But for this to work, we're just assuming that there's only one, and that makes things a lot easier in terms of finding where we want to occlude stuff from. So we use that function, and it searches for this component, and then it finds this game object, and now we can do our tracking based around that. Cool, so that's everything that happens on the first frame as soon as the game starts. Pretty simple stuff. We're just setting up a few things to be used later on, mostly to do with our audio event. Next, we have the fixed update function. Now, the fixed update function works, well, first of all, you may have heard of an update function. What that does is it performs tasks that we give it on every frame of the game. So if you're running at 60 FPS, it's going to run 60 times a second. Fixed update doesn't quite go off of, I forget every time, to be honest, but it doesn't quite go off the frame rate. It goes off a consistent 50 times a second, I believe is how it works. So 50 times a second, we're going to be doing all of this, okay? And the first thing we're going to do is we're going to check to see if the audio our audio event has ever been made virtual using the isVirtual function. Now, what does that mean? Well, virtual audio events in FMOD, they basically, if an event's made virtual, it means that the player can no longer hear it, but it's still playing. It hasn't stopped playing. It's just that the volume's not been turned down. The signal's just been kind of stopped for the player to hear. And the reason why you would do this is if you've got loads of instances of a certain sound and you don't want all of them to play. So, for example, what's a good example? Let's say the player's fighting like 100 enemies, right? Well, we don't want the sound of 100 enemies going trying to kill the player, do we? That's too much. So we'd make some of them virtual. We'd only have, say, 10 of them be not virtual, 10 of them that the player can hear. Maybe that might even be too much. You probably do less than that. But the rest are virtual. They're still playing, meaning that if a few enemies die, we can start to, hear the audio continue to play as it was. We're not starting again. So, if the audio is like halfway through, we can start hearing it from halfway through. But it just means that, if there's too many instances, we don't hear them all, essentially, and deafen our player. So we want to check if the audio has not been made virtual. If it has been made virtual and the player can't hear it, then there's no point in doing all this occlusion checking. So what we're going to do, which you'll see in a bit, is just make sure that things like that are, make sure this isn't virtual before we start casting a million lines, because obviously that's going to affect the performance. There's no point casting all these lines if the player can't even hear the sound. We want to save on performance by not casting them, when unnecessary. So that's what this function is doing, and it's basically it's checking true or false. Is the audio virtual or not? And just like with the get maximum distance function, it's going to output that to a variable of that type, where that function outputted a number, this function outputs a true or false value. So the audio is virtual variable, which I created up here, as you can see, is of the Boolean type, which takes true or false values. So now we need to do is check this variable, audio is virtual, to see whether or not our audio is virtual. Pretty self-explanatory, isn't it? Moving on. Get playback state. So, like I said earlier, we've got a variable up here called playback state, and I've called it PB for short. What we're going to do in a bit with this is we're going to check to see if the audio is playing. Just like with the audio being virtual or not, if the audio is not even playing, if for some reason we've, I don't know, written somewhere audio.stop, there's no point in, I don't know, what am I doing? There we go. Stop writing, Henry. Let's say, for example, we stop the audio playing at some point. Again, there's no point in firing all these line casts and making our game do more work than it has to, because we can't even hear the sound. So that's what that's checking to see. Or rather, sorry, it's not checking it just yet. All we're doing essentially is we're finding out whatever state the audio is in, and we're going to output it into the PB variable. So there's 5 different types of states that our audio can be. I think it's starting, so if it's starting to play, playing, if it's, in the progress of playing the sound, stopping, if it's about to stop, stopped, if it's completely stopped, and sustained, which is where, if I go into FMOD, where you've added, quickly Henry, you're stalling and embarrassing yourself. That's if you add a sustain point somewhere. And sustain points basically just hold the event in place and stop it from playing. Okay, so that's the 5 playback state types. And we're basically checking which one our audio is in. We're outputting that to that variable, okay? And again, just to recap, this is happening 50 times a second. So obviously these things can change. The audio might be playing at one point, stopping at the next. So we want to keep checking to see if these are, playing or stopping, which is why they're in the fixed update function. Next, we are basically using a fancy little function called distance. And this is going to be something we're going to use a lot. So all we're doing here is we're taking that, so all we're doing here is taking the listener distance variable, which is a float variable, which we haven't done anything with yet. At the moment, it's just empty, it's 0. And we're going to set it to a value, and that value is going to be the distance between our sound source and our player, whatever that might be. The way we do that is we use the distance variable within the vector-free, whatever that is, a struct, I guess. So you write vector3.distance, and then what you need to do is feed it to vectors, to coordinates, essentially, of the x, y, and z type. The first one we want to feed it is the position of our sound source, which, as we know, the way we get that, because this script is attached, let's go back to our music. There we go. Because this script is attached to the object that's playing the sound, all we need to do is access the transform component and the position coordinates within it, okay? So all we write is transform.position, and that is of the vector-free data type. So that works, right? Next is we want, where the listener is. So we do the same thing, but this time we write the listener, which again is that variable which we found in the start function. We found of the studio listener type. So again, our code basically searched for all the objects, and it found this object here because it had the studio listener component attached. Well, now we can find the transform component of that and the position coordinates within inside its transform component. So we do the same thing. We write listener.transform.position. So now we've got 2 vector frees. We've got 2 collections of coordinates. And what our distance function is going to very helpfully do for us is it's going to take those 6 numbers and it's going to squish them down and produce a single number, which is going to represent the distance between the 2. And then that is going to be stored within listener distance. So if we ever want to know how far they are, we just check that variable now. Nice and easy. Next is an if statement. So this is what I was explaining earlier. Like I said, the reason why we're collecting all this information is because we want to check to see if we should even bother casting our lines out. And this is what this if statement is going to do 50 times a second. It's going to check 3 things And if all three things are true, then we're going to start firing our line cast and checking for occlusion. So the first thing is, audio is virtual. Is that variable true or false? If it's false, meaning the audio is not virtual and it's playing normally, brilliant. That's one check done. We want to, if the rest are true, we want to fire our line. So that we're checking for that one to be false, basically. So if that one's false, next we want to check to see if the PB variable, if the playback state within it is set to playing. Like I said earlier, if it's not playing, if the audio is not playing, there's no point in doing this. So that's another check we make. Is the audio playing? Finally, the last check is the listener distance value, is that less than or equal to the max distance value? So quick recap, the max distance value is the value we pulled from FMOD. It's this value here, the last value on the distance attenuation curve, right? So the furthest the player can be before we start to, the volume's completely turned down. So is that, let's go back into our script, is the listener distance value, again, that is the distance between our sound and our player, is that less than that max or distance attenuation value? If it is, that means that the listener is somewhere on this graph, and the listener's going to hear the audio. So that means we want to start firing our lines and check for occlusion. Okay, so let's quickly go through those one more time. Is the audio virtual, or rather, is it not virtual? If it's not virtual, that means the player's likely to hear it. That's the first check. Then we check to see if the audio is playing. Finally, we check to see if the listener is close enough to the audio to even hear it. If all three of those things are correct, two of them being true and this first one being false, then we're going to start triggering this function, occlude between. If either one of those things aren't true, then this function doesn't get called and we save on performance, basically. The last thing in the fixed update function is this, line cast hit count. That's going to be set to 0, and that I need to explain in a bit, so we'll come back to that later. Okay, so occlude between. So this is a function I've created myself, and that's this big fat function here. So there's a lot going on, so let's break this down. First things first, as you can see, there's two parameter variables inside those brackets. Basically, what it's saying is for us to even call this function, we need to give it two values, which are going to be stored inside these variables I've declared here. So they're both of the vector-free data types, so they're coordinates, essentially. First thing we need to know is the coordinates of our sound, where that is in our world. And then secondly is the coordinates of our listener, where the listener is in the world. So if we go back up to where I called the function, as you can see, for the sound, I've given it the transform.position of the object that, oh, I've lost it again. The object that this script is attached to. So again, these coordinates here. And then for the listener, I've accessed the game object that has the studio listener component attached to it, and then got the transform.position coordinates of that. So like I said, so the object that this script is attached to is stored in sound, and then the listener's coordinates are stored in listener. Cool, nice and easy. Okay, now inside this function, there is a lot going on. So I think what I'm going to do, just so we can visually keep track of what's going on, I'll tell you what, we'll do this. We'll break it down one at a time. So I'm just going to move all that out of the way. We can talk about the first thing that's going on. So what's happening here is I've created a new variable of the vector-free data type. So like I said, this is going to hold three numbers, an x, y, and z coordinate, okay? Now, what are those coordinates? Well, that all depends on this function here called calculate point. Now, what it's going to do is it's going to take those variables that we fed into this function, so sound and listener, and it's going to stick them in another function, which is going to do some calculating for us based on a formula, which I'm going to show you in a bit. Now, this variable is called sound left, and the reason why, if I go back into Unity, what this is going to do is basically calculate that point that's to the left of the object that we want to start firing our line from towards the player, okay? And we do this multiple times. So we do one from the left, one from the right, and we do one above and one below. So before we start firing our lines, we need to find out where we're going to start, where the coordinates of those positions are. So let's go back into our script and work them out. So like I said, to find those coordinates, we need to use this function here, calculate point. So I'm going to quickly scroll down and show you this function here, calculate point. Now, all the functions up till now, you may have noticed they've started with the keyword void. Now, void basically means if you create a function with it, you're basically saying that, okay, I want this function to do certain things. For example, I want it to play out audio. However, I don't want it to return me a specific value specific number or true or false or a collection of characters. I just wanted to do stuff basically. But if we instead replace void with a certain data type, that could be a float, an integer, a boolean, we're saying, okay, I want you to do stuff, but I also want you to return me a value. So for example, if I set this function to float instead, I'd be saying, okay, I want you to return me a number that could be a decimal point. If I change that to integer, I'd say, okay, I want you to return me an integer, which is a number that doesn't have a decimal point. It's a whole number, essentially. What I've done is I've set it to... Oh, whoops. I've lost it. There we go. I've set it to vector 3, so it's going to return me with a set of coordinates. So now whenever this whenever this function is called, it's going to create a set of coordinates, which are then going to be stored inside my sound left variable of the same type, okay? Hopefully you understand that, because that confused me for the longest time. It's basically, the way I like to see it's like a calculator. We give it some values, which is what these variables are here. The values get stored within these. The calculator does its sum, 2 plus whatever, plus x plus y, doesn't matter, I'll explain in a bit, and then returns us with the result, which is almost stored within an instance of this function, which we can then store within variables, okay? So, calculate point. As you can see, there's a lot going on here. What this is doing is basically working out, okay, where is this point that I want to start this line from? Obviously, my aim is to get it to start from the left of the sound source. So how does that work? Well, it's all based on this beautiful formula that I found online. But if I go back into my game quickly, and let's zoom out a bit. In fact, I'm going to quickly tweak some things just to make this easier to see. There we go, that'll do. Okay, so let's quickly click off that. There we go. So as you can see, what we've got essentially is... Well, we know we want to fire a load of lines between our sound source. Sorry, I'm just trying to anchor this a bit better. From our sound source to our listener, okay? Now, the first one's obvious, isn't it? We just want to fire one from the center of each, okay? So that's nice and easy to do. We can just access... We know the coordinates because it's just their transform.position coordinates, so that's easy to do. But when it comes to all the things to the left, like, you know, the lines that start from the left and the right of the objects, we need to work those out. So let's say that where my mouse is now, let's say that that's one of the points that we want to fire a line from. So we'd fire the line from here to the player. And that would act as one of the lines that, you know, check to see if anything is kind of next to either of them to start occluding things slightly, right? Well, notice that it kind of forms, well, it does form, a right-angled triangle, okay? Where the right angle is here, in between, so you've got, how do I explain this? So you've got a line firing from the listener to the sound, or the other way around, which is the distance between the two. Then you've got a line firing from the sound to the point we want to fire our line cast from, and that is set, if I go back to our object, that is set by the sound occlusion widening variable. Oh, actually, there you go. We'll use that arrow. So let's say that arrow is where we want to fire the line from, right? So as you can see, we've got a right angle here. Okay, and that right angle is always going to be there. It's never going to change. The only thing that's going to change really is the distance between the sound source and the listener. But what's going to remain is the length between the point we want to fire the line from and our sound source, okay? So we've got quite a bit of information to go on. We've got a distance between the sound source and listener, distance between the point and the sound source. We've also got a right angled triangle. We also know the coordinates of the listener and the sound source. What we want to work out is the coordinates, based on all of this, of the position we want to fire the line from, okay? And that is where this formula comes in handy. All we need to do basically is plug all that information into this formula. So x1 and y1 sitting on the right angle, that's our sound source. That's the coordinates of my sound source. X2 and y2, that's the listener, position of the listener. N is the distance between the two, which, as I've shown, we can work out and store inside a variable. M is the distance between the point that we want to fire the line from and our sound source. Again, that's going to be set by the player with the occlusion widening variable. And then XY, that's what we want to work out. Where is that going to be? So that's what we use this formula for, okay? Now, it looks confusing, but the way I did it is I just focused on basically this line here, which works it out for the y coordinate, and then this line here, which works it out for the x coordinate, and I just plugged in my values here. The rest of it is just kind of proving it and explaining different ways that the formula works. What I also did, and gets me onto another point with this system is a little bit flawed because it's based on a formula that works on a 2D graph. What I did is I replaced the Y coordinate with the Z coordinate. When let's go back to Unity, so that when our player starts to rotate around the X and the Z coordinates, our points are going to sort of rotate with them, so the lines are constantly facing the player. Problem is, if the player starts moving on the Y axis, say for example the player starts jumping above. Hold on one sec. Let's try and. There we go. This is being a bit fidgety. There we go. So let's say the player starts jumping above our sound. Well, it kind of still works, but the kind of lines start doing this weird sort of flippy thing. So admittedly, that is a little bit of a flaw with this system. But if your game is kind of heavily based on the X and the Z coordinates, there's not much altitude to it, then this will still work. In fact, even if there is, it will still work pretty well. But that is something to consider when doing this. But anyway, because of that, because most games are based on the X and the Z axis and not so much the Y, that's why if I go back to the formula, I've replaced it in my script, all the Y coordinates with the Z coordinates. And then for the Y coordinates, when we start plugging that in our script, I just said, I'll just take whatever Y coordinate the object's on and just, put it there. So when it comes to the altitude of these points, it's just going to match whatever altitude our sound object is at and also our listener is at, okay? So yeah, so basically, long story short, this formula here, I've basically done some magic and turned it into this function here, okay? So for example, this line here, if I go back to my script, that is basically this line here. What you may notice is that in the formula, it's given us the plus or equals sign, and that basically determines whether you want this point here, x, y, or if you want minus x, minus y, which would give us a separate triangle. Now in our case, we want both of them, don't we? Because if I go back into Unity, find my music object again. There's a lot of fiddling in this video today. We eventually want, whilst we are currently trying to work out the point to the left of the sound, we are going to want the point to the right of it as well, aren't we? So that's why in my formula, I've done it for both plus and minus to give us both positions for our sound. Now, I think because this is taking quite a long time to explain, I think I'm just going to quickly sum this up how this works. So let's come back up to where we first called that function. So as you can see, well, sorry, actually, no, let's go back down to it. So as you can see, there's a few, just like with our occlude between function, the calculate point function requires some information which are going to be stored inside these variables here, A, B, M, and pos or negative. Basically what it's doing for A and B is it's just taking the coordinates of sound and listener, which we worked out earlier in the update function, and it's basically, without changing them, it's basically taking them into this, so we can start doing some calculations, okay? So now they're not called sound and listener, they're now called A and B, okay? M, that's pretty simple. M is basically occlusion widening. Like I said, if I go back to the formula, M is the distance between the point we want to fire the line at and our sound source. So M is determined by occlusion widening. So that's what we feed into the function, and that value is represented by M. Finally, pos or negative. So to calculate each point, we need to, like I said, we kind of need to do both. But for each one, we need to do the opposite. So pos or negative is basically a true or a false value that you have to choose. So for example, this variable here, which I'm using the function for, is called sound left. The reason why is because I want to work out the point which is to the left of the sound, okay? Now, like I said, to work that out, we need to do the formula for both plus and minus, but we need to do them for each axis, if that makes sense. So for X, we need to do, and I'm not sure if this is specifically wrong. Well, actually, let's find out. If I go up, true, okay, yeah. So this is what we do to find out the coordinate to the left of the sound source. For the x-axis, we need to use the plus symbol in that formula, but for the z-axis, we need to use minus. Now, if we wanted to find the point that was to the right of the sound source, we do the opposite. For x, we'd use minus, and for z, we'd use plus. So basically, by writing true or false here, we want to say, do you want to find the point that's to the left or to the right of the sound source, essentially? Then once it's done that and it's spat our numbers out into that formula, it's going to return the answer in the form of a new vector free, a new collection of coordinates. It's going to take the calculated x, it's going to take the calculated z, and it's just going to return us whatever y was originally. Like I said, we're not changing y at all. So it's just going to take the value of wherever we're calculating this from. So in our case, it's the sound source, and it's just going to give us back the value and not change it at all. Okay, cool. So that's how the calculate point function works. So now we've got a value, or now we've got a position in our world that, like I said, is sitting left and will always sit left to our sound source. But we need a few more. We need the one to the right of the sound source, one above, one below, and we also need to do the same thing for the listener. One to the left, one to the right, one above, one below. So now let's bring all this back. That's what all this is doing. We're just, oh, whoops. There we go. This looks like a lot, and it can be a bit intimidating, but what's essentially happening here is we're just repeating what I've done for the sound left variable, and we're just doing it again and again and again and again, but we're changing a few things. So for example, like I said, to find the position that was to the right of the sound source, we give it the same sound position, the same listener position, the same occlusion widening value, but this time we flip the values, we flip that plus or minus round, so we say false instead of true, okay? And you can go through these yourself and you can kind of experiment with them. Like I said, if you want to even add your own points to make, fire more lines and make this even more detailed, you can based on all this. But if I went through all this, I'd be repeating myself, essentially, so we're not going to bother with all that. So now we've got our 8 points. We've got one to the left, one to the right, one above and one below, both the sound source and the listener, and we've also got the center points of both of them, which we don't need to do a calculation for. So now let's make let's make things easy for ourselves, and let's make some space in this function. Let's have a look at what's going on here. So now we're firing a new function called cast line. Cast line is pretty simple. Cast line is firing our lines. So let's make some space and let's focus on our first one. Cast line. Now, as you can see, cast line, in fact, let's go to the function where it is. There we go. So here's cast line. So just like with our last two functions, it requires some information for it to work. It requires a start position where the line is going to start from and an end position where the line is going to end from. In this example here, I'm saying, okay, I want you to start from that position that is to the left of the sound, which is what we just calculated. So start here, and I want you to fire to the position that sits to the left of the listener, which would be this position here, which again, we would have already calculated with our calculate point function. So this is going to fire a line from the left of the sound to the right of the listener. If I quickly play our scene, there's a lot going on. In fact, maybe I can even make this a bit easier to see. There we go. So in this example, it's this point here, and it's this line here that is what we're trying to tell our function to fire. So what it does is it creates a new variable of the raycast hit type. Raycast hit is basically a variable that collects information whenever a raycast or a line cast, which are, that's the name of these lines, whenever they hit something, essentially. Next, we fire our line. This line here, let's make some space so we can see it a bit clearer. Physics.linecast. This is the function that fires our line. And again, it requires some information. It requires a place to start at, which again, like I said, is the left of our sound source. A place where it's going to end at, which is going to be to the left of our listener. Then it requires a raycast hit variable to output all the information it collects. So in our case, we're saying, okay, all the information you collect if you hit anything, we want you to output into the hit variable, which we can check later on. And then finally it says, what layers do we want me to check for? And that's the occlusion layer variable I told you about earlier. So in our case, the line is only checking to see if it hits anything of that belongs to the environment layer. Next, we have an if statement. We say, okay, we fired the line. Now we want to check this hit variable. Now, did this hit variable hit a collider at all? What we mean by collider is if I quickly click on one of our blocks in our world, let's say this one here, zoom in a bit, this wall, you'll notice it has a box collider. Box collider is a component that prevents things from going through each other, essentially. They collide. So we want to check to see if our line, whilst firing, hits an object that has a collider and is of the environment layer. If it did, then we want to do all the stuff in here. So what we want to do is basically take the variable linecast hit count, and we're going to add a number to it, okay? Now, linecast hit count, if I scroll all the way back up, is this variable here. It's also the variable that I was setting to 0 at the end of every sort of, not frame, but every, like I said earlier, 50 times a second, we're going to be checking this stuff. Well, this is going to happen once, all the other checks are going to be made. It's the very last thing that will happen. Well, for each of those lines that we're firing, we're basically going to, for everyone that collides with a wall or something that we want to start occluding our audio with, we want to count the amount of things that have occluded with us, essentially. So that's what this variable here does. You can see I've just incremented it by 1 by writing plus next to it. So for each line that fires, for each one that hits a wall, the number of 1 is going to be added to that variable. So we're counting, essentially, how many objects are hitting our lines. Then what it's also going to do, if our line hits something, is it's just going to draw a line in Unity, and this is just a debug thing. It's just so we can see, if I go back to our things over here, obviously this whole time we've been seeing green and red and blue lines. That's what this line is doing. It's just drawing them so we can see it in the editor. That's obviously something you won't see when you play the game, or the player won't see. It's just for us. And the way that works is we give it the start position of the line, the end position, and the color. Because this is the line that's going to be drawn if it does hit something, does occlude, I've said, okay, I want you to set the color to red so it can visually tell me this line is occluded. So that's what happens if the line does hit something. If it doesn't hit anything, then we want to still draw the line, but this time the color is going to be based off of a variable I've created called color, spelled correctly. So if I quickly scroll back up to our occlude between function, right at the end there's this if statement. So just like everything else we've been talking about, inside most of these functions other than the start function, this is going to happen 50 times a second. It's going to basically check the values of both the player occlusion widening variable and the sound occlusion widening variable. If either one is 0, then we're going to set the variable color to be blue. It's going to hold the color blue inside side of it. If either one of them are larger than 0, so basically if those points are wide and they're not all coming from one center position, then we set it to green. This was just like a visual thing. You don't have to add this. This is a visual thing that I just included to make things a bit easier to see in Unity. But notice how if the line doesn't hit anything, we don't add a number to that count, okay? So that's the cast line function. That one's pretty easy to understand. So as you can see, we do that multiple times. So we do that for, I've lost it actually. Oh, there it is. I thought I was missing one there. So let's quickly bring all these back together. So I've decided to do this, I think 11 times in total. That's how many times I'm firing that function and creating a new line. And as you can see, I do it for all the points I've calculated. So we start from the sound left to the listener left, then we go sound left to listener's center, then we go sound left to the right of the listener. And we do that multiple times. As you can see, we also do it from the center of the sound, the right side of the sound, and we even do it from above the sound and below the sound. So now 11 lines have been fired out into our world. Okay, now that we've sort of hopefully understood all that, I'm just going to quickly fix my function a bit, just so everything's nice and neat again. And I've already explained what this does here. So let's quickly recap on the occlude between function, because there's a lot going on. So we calculate the points we want to fire our lines from, which are 8 points in total, excluding the center points, which we don't need to calculate for. Then we fire line casts for each of those points. For me in total, that's 11 points. If you want, you can fire more lines to make it more detailed. It's up to you. We also then quickly check to see what values our occlusion widening variables have been set to. And that'll determine basically the color of the lines for us to see in Unity. And finally, once we've done all of that, we finally got a collection of how many lines are being occluded inside our, I can't remember the name of it now, what was it called? The line cast hit count variable, which is basically what this function has been trying to do. It's basically collecting how many lines are being occluded once fired. Once we've done all of that, we do the last thing in this function, which is set our parameter. So the final function I've created is called set parameter. And all this does is one simple thing, is we go back to FMOD, we take our audio event, we take the parameter, which this method assumes you've created, and it sets a value for it. So how about we take a little bit of break from all the coding stuff, and let's have a look at FMOD and this parameter. So what this script requires you to do for this to work is to create a parameter in your event and call it occlusion. What you then need to do on either the track that's playing your audio, but if you've got multiple, you'll probably want to do it on the master track, which is what I've done here. Take one of those tracks, and create some attenuation lines. So what I've done on my master track is I've added a low pass filter, which you could do right click, add effect, FMOD, where would it be? FMOD depreciated? Is that what that says? God, my reading was never good, but whatever that says there. Go there and select the FMOD low pass filter effect. Add that to your chain. And what you want to do is basically right click on the cutoff, and you want to add automation. I've only got the option to remove it because I've already added it. And you'll do the same for volume, and you can even do the same for reverb if you wanted to add that as well. What you'll then do using your parameter is you want to set points on your parameter saying where you want the cutoff effect to sort of start and end. So as you can see, when my occlusion parameter is set to 0, I've made sure that there's no cutoff, so that we can hear the audio full and all the frequencies within it, and the volume is at 0 decibels. But then when my parameter is set to 1, I then want the cutoff to be set to 1 kilohertz, so we only hear frequencies below 1 kilohertz, and I've set the volume to -6 decibels, okay? And then anything in between will be determined based on this graph here, okay? So say we're at 50, or sorry, say the parameter is set to 0.5, we'll get a cutoff of about, I don't know, 10 kilohertz, anything below that, and a value of -3 decibels for the volume. So what's going to happen in our script is going to calculate, depending on how many lines are being hit or hitting a wall instead of our listener, that's going to determine where this line here on our parameter is going to sit, and therefore where our, if you look at the bottom here, where the cutoff of our frequency is going to be, creating that occlusion effect, okay? So I've added that to both my talking and my music events, and you can adjust these values for each of your events. So you can see, for example, with the music, I've changed the cutoff ever so slightly and the volume ever so slightly. It's up to you. So going back into our script, to do all that, in order to set the values of that parameter, we need to use this function here, set parameter by name. Now, I made a whole video about how not only you can use set parameter by name, but also set parameter ID, another function that sets a parameter's value. So check that video out. That'll be, actually I can point now, can't I? Up there above me. So, audio, that like we know earlier. So we already know that audio is where is a reference to the event we're controlling. So we use set parameter by name. We give it the parameter we want to affect, which is occlusion. Make sure you get the name exactly the same as you've written it in FMOD. And then we don't fire. We give it a value. And the value we give it is the value of our line cast hit count. So how many lines actually hit a wall. Let's say, for example, it was 3. So let's say 3 lines hit walls. We take that value and we divide it by the total amount of lines that are being fired. Now, as I said to you earlier, I'm firing a total of 11 lines because I'm calling the cast line function 11 times. So the value I've put here is 11. But if you want to fire more lines, you'd obviously just have to bear that in mind. You'd have to change the max value here that you add. So 3 divided by 11, I have no idea what that is, but let's go back to our function. That would roughly be around just above 3, wouldn't it? It'd be roughly here. So that's the kind of, let's go back to talking. So we'd get an occlusion value, or the cutoff rather, would roughly be about 7 kilohertz, and the volume would roughly be about -2 decibels. Now, the last thing we need to do is basically reset this count. If we didn't reset it, remember this is happening 50 times a second, so if we didn't reset it, these lines, or this value, because we're incrementing it every time a line hits a wall, it would keep incrementing 50 times a second. So let's say our player and our sound were just not moving, but 3 of those lines were hitting a wall. Well, that means that 50 times a second we'll be adding 3 to our variable, and that's obviously going to screw this up. Our calculation, we'd have like 586 divided by 11, and that would ruin our occlusion. So the way we reset it is we go all the way back up to our fixed update function, and right at the end we say line cast hit count is set to 0. So at the end of every, interval, I suppose, 50 times a second, this is going to be set to 0 again, ready for it to then be, for the lines to be counted on the next interval. And the way you make sure that that's the very last thing that happens in your script is you put it at the very end of your fixed update function. So most of these functions are being called within the occlude between function, which is being called before the line cast hit count. So our checks are made, can the player hear our audio? Then we fire the occlude between function, which not only calculates our points, but it also fires our lines, checks to see whether any of them hit our listener or a wall, and they also then it starts counting how many hit a wall, and then adds it to the line cast hit count. Once it's done that, it also sets the parameter for our event in FMOD, and then it's done. Essentially, it's done everything. So once it's done all of that, line cast hit count is then set to 0. So because, as you can see, it's at the very end of fixed update, and the rest of our script is happening inside the occlude between function, which is being called before we reset it, we can guarantee that that's the last thing that happens in our script. We obviously want to make sure we don't reset it before or in between the count, because that's going to screw things up. But anyway, I think with that, we are done. My God, that took ages. I didn't realize it would take so long to explain. Woo! So glad that's done. But anyway, yeah, I hope you enjoyed that. That's pretty much how this script works. Like I said, if you want to just copy this and use it for yourself in your own games, you can. You just go to my website, scottgamesounds.com, and I'll have a link for you to copy it out, slap it into your own games, have some fun with it, and feel free to even tweak it if you want. Like I said, if you want to add more lines or less lines, hopefully now you understand how this script works, and you can do that. So for example, one thing I didn't do is I didn't fire a line from the center of the sound to above the listener. So the way you would do that is you'd create a new cast line function, or not create a new function, but you'd fire the cast line function again, and you'd write sound. We'd just write sound because we want to fire it from the center. So we'd write sound, and then you'd write listener above or listener below. It doesn't really matter. It's up to you. Just bear in mind that the more lines you fire, the more work that means your game's going to have to do. If you've got a lot of sounds that you want to occlude, they're all going to be firing about 11 or 12 or 13 lines. So you don't want to overdo it. Hell, I might have even overdone it with this. So that's something you might have to experiment with as well. If you start to notice performance issues, maybe this is something to consider as a culprit for that. Just trying to think if there's anything else I've missed out. Well, I think I've got it all. I guess the last thing I want to just show you is a demonstration of... You remember at the beginning how I said we want to check to see if the player is even near enough to the audio to even hear it before we fire our lines? Well, if you look at the Scene tab in Unity, if I get closer, there you go. You can see the lines will appear in Unity when we've hit that limit, or rather when we're within that range of distance. If I then move away from the sound, not only do the lines stop firing, but we stop seeing those green and blue and red lines. So that visually indicates to us that brilliant things, you know, we're not firing the lines unnecessarily. So that's something you can check for. Okay, now I think that's definitely everything I've explained. So thank you so much for watching that. I really hope you've enjoyed this. I'm really enjoying sort of complicated or advanced scripts to do with 3D positioning and 3D audio using FMOD and Unity at the moment. So I definitely hope to do some more. And like I said, there are a couple of flaws with this system. It works pretty well. But it's not perfect, so if I come up with some more improvements, I'll definitely make another follow-up video for you to, you know, indulge and learn about, and then you can use the new script for that. It's going to be amazing. But yeah, I think we're done. 2020, first video. Love it. And I hope you enjoyed the face cam as well. I thought this would make things a bit more personal. Yeah, thank you so much for watching. I'm exhausted, as you can tell. If you have any recommendations for something you want to see on this channel, feel free to leave a comment in the description. I'll be happy to get back to you. Email me if you have any questions about the course, the FMOD Unity Essentials course. Oh, that's gone. Never mind. Yeah. Again, drop me an email, drop me a comment. I'd be happy to help you out with it. If you have any questions on this script, what we've done today, occlusion, feel free to send me a message and I'll try and explain it best I can. Thank you so much for watching. I've been Henry Scott, and I'll see you in the next one.